use these in order to build predictive models. How do we do that? We use as input well location, reservoir characteristics, well completion stimulation on an average per stage basis, operational constraint, and we use monthly production rate as our output. And when we do that, we history match every single well in the asset. For example, here for this pad that has two lateral, you will see an x-axis the time, on the y-axis on left you will see the gas MSCF per month, and the dots are actual rates from the field, and the line is what we call the top-down model, which is a reservoir modeling, reservoir management technology that is done, a workflow developed specifically for mature assets, or the assets where they have a lot of data, and it is completely data-driven. And on the y-axis on the right, you have cum gas production, and the two shades that are right on top of each other, the green is cum reservoir model, and the orange is actual field. And of course, because they're on top of each other, you don't see two, you see only one. And so this is history matching of another well in a multi-pad. And during this modeling process, you essentially history match every single well in this full field model. And here you see it for another one. This is history match for another one. These are some examples of some of the analysis that we have performed in Marcellus Shale. And when you put it all together, what you're looking at is for the entire asset. Again, you see x-axis time, and in the bottom, these bars are the number of wells that are coming into production at any given time. And you have dots to be actual production from the wells from the entire asset, and of course the top-down model is, or data-driven model is in full line. Now, how do you validate? How do you know that these wells are correct, or these models are correct, or you can trust them? Of course, when you do history matching, no model is correct. As they say, all models are wrong. Some models are useful, and I consider this to be a useful model, although I don't think it is and the absolute truth, obviously. But in order to validate, to see how much we can trust the result that comes from a model such as this, we had data from 2006 to 2012. We used that data to train a model and history match it, and then we had the data from 2012 to 2013, that 1 year. We did have it, but we didn't use it in the model. We deployed the model that we've developed in the forecast mode, in the predictive mode, and then forecasted this 1 year production, and then compared it with the data that we have. What we call this a blind history match. And let's see what happens if you do that. When we did that, as you see, the forecast, so the model was developed up to this point, and it history matches the entire asset really well. And of course, this was developed for every single well. Then the value for all the wells are added together in order to show this here in this plot. And then this is complete forecast. This is blind history match, where the model shows how it follows what is actually in reality. And we have done it for individual wells. Two examples of it right here. We have about 4 to 5% error, and as you see, this is not decline curve analysis or curve fitting. This is actually a reservoir model running in forecast mode after. Now, then how do you, another way of validating the model is for locations that when you build the model, there was no wells in that particular location. A new pad that was drilled after the model was developed is shown here for wells, and we have about 6 to 8 months of production from that, and then we compare what model would provide in line versus the actual data from the field. And you see that for these 4 pads, these results are not bad at all, but 10 to 15% wrong. So this reasonably provides you with a validation that this model can be used in order to tell you if you drill and frack in a certain fashion in a certain part of the reservoir, then what can you expect? So now let's look, how can I use this model? The first thing is look back analysis. Here we do a process that assess the efficacy of the completion in a given asset and to identify enhancement opportunities. And the way we do that in look back analysis, we look back on the effectiveness of the frac job that was already performed for all the wells. For each well, we know the location, operational constraint, and reservoir characteristics are kept constant. That would not be changed. But we examine the impact of changes in completion and frac job that was performed. And we perform Monte Carlo simulation. These models have very small footprint, so you can make 1,000 runs literally in minutes. It's not like a numerical simulation. So what we have done, we kept the well configuration, production constraint, operational constraint, and reservoir characteristic constant, and we change these parameters: number of cluster per stages, number of shots, stage length, fluid volume, pad volume, proppant, treatment pressure, and all that. The frac company, we change these and we run the model thousands of times. And it says for that well located in that place with that reservoir characteristics, given all possible completion strategies, we could have a P10, P50, or P90, as you see here, possible. But what happened essentially? For this particular well, the frac job was made, had a productivity of this much, which essentially represent a P45, which is reasonably expected. So when we do that for all the wells, what do we see? These are wells that are categorized as poor or average well. This particular well has this distribution in uncertainty analysis, and you can see that this well has literally performed as such, and it's less than P90. So this well was not fracked in a nice way. This one, on the other hand, is fracked as expected because the actual value of productivity is about P50 that it could get, and in this one actually you get almost a P10. That's a very good frac job. So these are examples, these are actual wells and the examples of how they were performed. And if you do look at an average well, you can see we had a P90 well, we had a P50 well, and we had a P10 well. So in other words, what we're trying to say here that we have done very good jobs in our fracking, we have done average jobs, and we have done poor jobs. So, and this is for good wells, two more examples. And when you do that, so what I would like to do is I'm going to classify if my current practices of a given well falls between P0 and P19, I call it excellent frac job, between 20 and 39, exceeding our expectation, between 40 to 60, as expected, and anything below that does not meet expectation, or it's a poor frac job and can be. And when we do that for this particular asset, for one of the assets, we'll see that in this asset, about 75% of that get a grade A, B, or C are either excellent, exceeding expectation, or meeting expectation, whereby 25% of them get a grade of D or an F that actually are poor frac job and can be done better. And we can find out exactly what caused one to be good and what caused one not to be good.